A radio telescope is simply a telescope that is designed to receive radio waves from space. In its simplest form, it has three components. 1. Are more antennas to collect the incoming radio waves. Most antennas are parabolic dishes that reflect the radio waves to a receiver, in the same way as a curved mirror can focus visible light to a point. A receiver and amplifier to boost the very weak radio signal to a measurable level. These days the amplifiers are extremely sensitive and are normally cooled to very low temperatures to minimize interference due to the noise generated by the movement of the atoms in the metal. A recorder to keep a record of the signal. Most radio telescopes nowadays record directly to some form of computer memory disk as astronomers use sophisticated software to process and analyze the data. The antenna. Parkes has a parabolic dish antenna, 64 meters in diameter with a collecting area of 3,216 square meters. The dish is made up of aluminium panels supported by a lattice work of supporting struts. The waves are reflected and focused into a feed horn in the base of the telescope's focus cabin. The dish has a mass of 300 tons and distorts under its own weight as it points to different parts of the sky. Receivers. The weak radio signals are channeled by the feed horn into a receiver located in the focus cabin located at the top of the telescope. Radio receivers amplifies the incoming signal about 1 million times. Parkes has a suite of receivers that are optimized for different frequency ranges and applications. The receivers are cryogenically cooled, typically with helium gas refrigerators that cool them to about 10 Kelvin to minimize the thermal noise in the electronics that would otherwise swamp the incoming signal. Recorders. The amplified signals are carried by fiber optic cable from the receivers in the focus cabin down into the tower where they are stored on computer disks. Depending on the type of observation, some processing of the data is performed on-site using computers in the tower. For pulsar observations, the rate at which data is received can be extremely high.